Today we'll discuss on the secondary storage, which is your hard disk drive. So I have shown you this particular diagram earlier, which is nothing but the magnetic disk architecture, that how a magnetic disk will look like. So in this particular diagram, you can see that a magnetic disk is the combination of many what we can say the platters. Okay, so we have many platters, and these platters will have two surfaces from where we can read and write. So both the surfaces are used to read and write. And then if you can see, there are sectors. So the smallest unit uh, of the storage in the magnetic disk are called sectors, and there is a track. So the hard drive, let's say if we take the one surface of the platter, and this particular one surface is divided into number of tracks. So all those are number of tracks, and each track is divided into number of sectors. So the sector size will be the same. So this is nothing but the sector, and this is nothing but the track, and this is one you can say surface. So we have platter. One platter has two surfaces. One surface may have different tracks, different tracks, and each track will have different sectors. So this is the hierarchy of the magnetic disk. The read-write head will keep its head to a particular place in the disk, and that particular place are nothing but the sector. So from the sector, the read-write head will read the data, okay, and provide it to the based on the user's need. Now the rotation is happening here. It is showing the clockwise rotation which is happening. The read-write head can move into one direction, right? This is the direction of the movement. This is the direction of the movement. This is one direction. So either it will go here or it will go here, and the disk is moving, okay, through the spindle. Now this is the first commercial hard disk drive, the picture of first commercial hard disk drive in 1956, which is developed by IBM, called Ramdeck computer, including the IBM model 350 disk storage system. In this system, 17-bit character are used in one sector. The platter size is 50 into 24 inches. And the access time here, it is less than 1 second for one sector. So one sector access time is around less than 1 second. And today's we have the magnetic, which is the hard disk drive we have, or we have the solid state drive, right? So solid state drive, the concept is different, right? Hard disk drive is working in a magnetic disk. A magnetic disks are there in the hard disk drive. So the concept of these two are totally different. And the solid state drive is more or less using the flash memory, which we generally use in pen drive and all. Now let's see about the disk scheduling here. Now the operating system is responsible for using hardware efficiently, right? So all hardware will be maintained using operating system. For disk drives, this means having a fast access time and disk bandwidth. Now, what is the meaning of efficient management of the hardware related to the disk? It means that We should have the fastest access to a particular data which we want. And second is the disk bandwidth. Now, the next goal is to reduce the seek time. So what is the seek time? The seek time is the time when the read-write head will reach to a desired sector. This read-write head will reach to the desired sector. So that time is called seek time. The time taken to reach up the desired track by the read-write head is called seek time. Now the disk bandwidth is the total number of byte transfer. So bandwidth is total number of byte transferred divided by the total time between the first request for service and the completion of the last transfer is nothing but your bandwidth. Okay. Now in the disk scheduling algorithm, there are many disk scheduling algorithms that we'll see one by one. To reach that particular algorithm, we'll see some more concepts related to disk scheduling. So there are very many sources of I/O requests, right? So input-output request could be from many sources. Operating system can initiate the request, or there may be the system processes which may request, or a user processes which may request the I/O. The I/O request includes input and output mode, means it is either writing into the drive or reading from the drive. The input means we want to write into the hard disk drive or we want to read from the hard disk drive. So for that we need the disk address, memory address, number of sector to transfer, right? OS maintain queue of request per disk or device. Now OS maintain a queue. This particular queue will tell me that which particular sector we want to access. So because we have the operating system is maintaining all these queues, so queue will be served one by one. Idle disk can immediately work on I/O request, right? So if we have the idle disk which doesn't have any request, so it will work on the I/O request. But if it is busy, then it will follow that particular queue. So that queue will be maintained by the operating system. It is a request queue, and request for hard disk drive access. Optimization algorithm only makes sense when the queue exists. So we have different optimization algorithm, and that optimization algorithm, we work on the queue. So if we have the queue, then only we can say that which particular request has to serve next, right? But if it doesn't have the queue and if the system is idle, so there is no use of optimization because we have only one request. Note that drive controller have a small buffer and can manage the queue of I/O request. So the operating system maintain in the drive controller. So we have the controller of the disk that is having the buffer, and that buffer is used to manage the queue. Several algorithms exist to schedule the servicing of the disk I/O request. The analysis is true for one or many platters. So now let's assume that we have these requests. Let's say we have 200 sector in the disk from 0 to 199. And these are the requests that is coming into the queue. So this is my request queue. So this is my request queue right now. And using this particular request queue, I would like to serve the request of the hard disk drive access. Okay. So first it required 98 sector, then it required 183, then 37, then 122, then 14, then 24, then 65, and then 67. Now, what is my position? My position in that particular platter is in 53rd sector. Okay, I am in the 53rd sector. Now, I want all these things. I want to serve all these things all these requests. I am in that particular position. This is my initial position. This is the initial position, my read write head. Now I have to move around and serve all the requests. So to serving all the requests, we have different scheduling algorithms. The first scheduling algorithm is called first come first serve. So it depends upon what is coming in your queue. So if your first request is 98, so 98 will be served. Then next request is 83, 83 will be served, 183 will be served. Then the next is 37 and 37 will be served. And that way it is going to serve up to 67. Shortest seek time first is the second algorithm, which is again an optimal algorithm. Now here what will happen is, if I am in the initial position of 53, so I'll find out in the queue that which is nearest to 53. Okay, and I'll go into that particular sector to serve, right? So first I'll serve that particular queue, which is the distance from 53 is the shortest. So I'll calculate that, and then I'll go to from there I can go to the next one, from there I can go to the next one. In that way I'll go. So this is called shortest seek time first. So whoever is seek time is shortest will serve that particular request. Now the next is the scan. Scan is also called like elevator algorithm. So we'll go at a particular direction and we'll go up to last, and then we'll go into the different direction. So just like your elevator, if your request is coming from the ground floor to the third floor, so the elevator go to the third floor. And let's say we have the request like 3, 5, 6, 7, and 8. And let's say I have the 10 floors. So it will go up to 8 to serve all the requests, right? Let's say if the initial position is 5th, and I have given the direction that you have to go up first. So it will serve 5 and then 7 and then 8. And let's say, and it is an elevator, so it will go up also. So that if there is a dynamic request into up a floor, so it can serve. And after going to the 10th floor, it will go again downwards, right? Now C-scan is the enhanced version of scan, in which we assume that if it is going up, then it will start from the 0. So you assume that the sector is like this, right? So let's say I am in a particular sector. So the assumption is different. If I am in that particular sector, and this sector is, let's say 0, this is 1, this is 2, this is 3, in that way. So if I'm moving around, if I'll reach here, let's say this sector is 99. So I'll reach here, and from here I can reach to 0 again, right? So some assumption is this. If the assumption is like that, if it is moving from that particular direction to that direction, and from that direction, if it has to move from up to here, so it is saying that it is a cylindrical, means it is the starting point and the ending point will be the same, of wrapping off that. So cylindrical scan is the algorithm that has been applied there. Then look is the variation of scan, and C-look is the variation of C-scan. So we'll see all these disk scheduling algorithm one by one, and we'll see how much seek time it is taking